Alright, so today I'm going to be talking about the anatomy and physiology of the retina. So just to start off, to get a better understanding of the retina, I just made some key points. It is the innermost tunic of the eye, so it's located kind of a little further back inwards. It usually appears as a purple reddish color, and it is thin, delicate, and has a transparent membrane. In the photo next to this slide, I provided just a little anatomy of the eye and where things are located, just to help us get a better understanding of where the retina is located visually and how important it plays into the pupil, the cornea. So yeah, I really like this photo. It's coming up a little blurry here, but it was very helpful for me to get a visual of that. And it locates the optic disc back here, the optic nerve, and how that correlates with each other. Alright, so in this slide it talks about the regions of the retina. So the first region I like to talk about is the optic disc. So in the optic disc, all the retina layers terminate here, except the nerve fiber. That's the only thing that doesn't terminate in the optic disc, which is essential to the retina. Also, which is important to the retina, is the macula lutea, which is a photo-optic vision, and it's the most sensitive part of the retina. It's situated at the posterior pole of the eyeball. So over in this photo over here, it helps you a little understand where the posterior pole is located, so we know that the macula lutea is right near there as well. The third one is the peripheral retina, so it's divided into 4 regions, near, mid, far, and the ora serrata, which are also located on this image to the left, which also helps you get a better visual of where they're located. This makes up the rest of the retina, and it is responsible for our sight and night vision. Okay, so this is the physiology of the retina. It consists of photoreceptor cells, rods, cones, and ganglia cells, which we will talk about more in the next few slides. That converts light energy into nerve impulses. So that travels through these photoreceptors and then into the nerve impulses that alert us to be able to see and convert that light energy as well. These electrical signals are passed via the optic nerve to the visual cortex, allowing us to visual our surroundings, which I think is very interesting. So in this photo to the left, just is also just a better photo for us to understand the photoreceptors, the cones and the rods, the ganglia cells, and the bipolar cells too. And we will get into the retinal pigment enthelium in a minute. Alright, so this slide I just put a difference of rods and cones. These rods and cones are really essential to the retina. They're distinguished by the shape and morphology of their outer segments. The rod itself, the outer segment, is more of like a cylinder shape and consists of membranous discs, which are separated from the plasma membrane. The outer segment is generally thinner than cones. In cones, they're usually shorter and tapered, and they're continuous with the plasma membrane. In the inner segment, it contains long thin mitochondria for both the rods and the cones. And the synaptic regions, also known as spherules in rods, which are generally smaller than cone terminals. In cones, they're known as pedicles. The function of the rod is for scotopic vision, so in low light levels, and peripheral vision, so our side vision. And then the cones are important for daytime vision, color vision, and visual acuity. So the retinal pigment enthelium is also a very important part of the retina. It's the outermost layer of the retina and makes up a single layer of hexagon cells which contain pigments. It's firmly adherent to the underlying brush layer and loosely attached to the layer of the rods and cones. In this photo right over here, located to the left, it shows where the RPE is located, which is right near the retina. They have very important functions, this RPE. It's usually to transparent nutrients and ions in water, and also to protect against photooxidation. So some functions are also manufacturing of pigments absorbing light, like I said, and provides mechanical support to process of photoreceptors and renewal of photoreceptors and recycling of vitamin A as well. These cells are also phagocytic. And they also shed photoreceptor membranes as well. So this photo is coming up a little blurry, but it did give a better representation of where the rods and cones are located as well, and where the RPE is as well. And that is all.